When a microorganism such as E. coli is grown on glucose, it must synthesize all of its amino acids. If an amino acid, such as histidine, is added to the medium, the organism can turn off the synthesis of the enzymes needed to make histidine. In the absence of the amino acid, a regulatory protein called a repressor is made, but it is unable to bind to DNA and prevent transcription. When the amino acid is added to the medium, it enters the cell, reacts with the repressor, and activates it so that the repressor now binds to the operator site on the DNA and turns off the pathway by blocking RNA polymerase and preventing messenger RNA synthesis. When microorganisms such as E. coli are grown on glucose, they do not synthesize the enzymes needed to degrade other growth substrates such as lactose. In the absence of lactose, the regulatory protein, called a repressor, binds to the operator site and blocks transcription. When the substrate, which is called the inducer, becomes available, it reacts with the repressor and inactivates it. The repressor can no longer bind to the operator site and transcription can proceed. Regulation of catabolic pathways involving a repressor that is inactivated by the inducer is referred to as negative control. Some degradative pathways are regulated by an activator protein. An activator is a regulatory protein that facilitates transcription by binding to DNA. Activators must react with the substrate that they regulate, such as arabinose, before they can bind to the DNA. The binding of the activator to the activator binding site on DNA enhances the ability of RNA polymerase to bind to the promoter site. In the absence of the inducer, the activator cannot bind to the DNA. RNA polymerase is unable to bind to the promoter site and transcription does not occur. Regulation of degradative pathways involving an activator that is activated by an inducer is referred to as positive control.